Hi, I'm Curt Frye, and in this movie, I will show you how to use a mathematical construction called a Markov chain to model how many bikes will end up at different stations at the end of a commuting period within a city. The sample file that I use is Markov Movie 04, and I have put a link to this file in the video description below. If you look to the right, you'll see that I have a map or a model of a bike rental system. There are 8 stations. We'll assume that the blue stations at the top are in fact in residential areas where people live, and then the 3 at the bottom, which are in gray, are places where people work. The idea is that this would represent the morning commute when people travel from their home or perhaps the end of a public transportation line to the downtown, and they choose to use bikes to do that. On the left, I have 2 copies of a transition matrix that shows where trips start and end on a percentage or probability basis. Starting in cell C4, a trip from S1 that comes back to S1, in other words, the bike is returned there, happens about 5% or 1 time out of 20. Going from S1 to S2 happens 3%. S1 to S3, 5% of the time, and you can see the other percentages there. And again, our goal is to determine, or at least estimate, the number of bicycles that will end up at each of the stations at the end of this commuting period. You can do that by multiplying this matrix by itself multiple times. Sometimes you'll have to go up as high as 20 or 30 times. If you have a large matrix, in this case, we can probably get by with less. So let's see what that process looks like. Now I can enter in my formula. So I'll type equal, and we'll do matrix multiplication. So that's MMULT. The first array is C4 through J11. And then, because I do not want this reference to change, I'll press F4, and that makes it an absolute reference. That's what the dollar signs mean. Then a comma, and I'll select the second copy of the transition matrix, which is C14 through J21, then right parentheses, and I'm leaving the second copy of the matrix reference relative, so it will update when we transfer the calculation. And I'll press enter. That is the result of the multiplication. So that looks good. Now I will click cell C23, press Control-C to copy, and I'm going to copy down the formula. And our goal is to continue multiplying, doing matrix multiplication, until the values in each column are about the same. And they will get pretty close fairly quickly. So I'll click cell C32, Control-V. There's another copy. I will press Control-C to copy that formula, click below with 1 blank row or 1 blank cell between the cell I selected and the result above, Control-V, going down, and it's looking like the values are starting to get pretty close. So copy cell C41, click in cell C50, Control-V. That's pretty good. Copy again. And C59, Control-V. Might not take too many more. Copy C59, click in C68, Control-V. And I'll copy C68, click in cell C77, Control-V. All right, we're getting very close. I think I'll just do one more. So I will copy the value in the formula is C77, C66, Control-V, and yeah, that's looking very good. So what I can see from the result is that on average, we can expect about 3.7% of the bikes to end up at Station 1, 3.4 Station 2, about the same for Station 3. Station 4 will have 8%. Station 5 will have 10%, 0.099, rounded up. And then 18% for Station 6, 34% for Station 7, and call it 19% for Station 8. And again, these numbers represent the percentage of bikes that will end up at each of the stations at the end of this transition period. I hope you enjoyed this video, And if you did, please like it and subscribe to my channel.